right. So today we are going to talk about graphing parabolas and how to do so efficiently. Please copy all of these notes onto the note page and pause as you need. We will be graphing from standard form, which is the form y is equal to ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is that number there with no variables attached. So, the first order of business is to find the axis of symmetry. And remember, this is the mirror line that goes through the middle of the parabola and will help us make our graphing faster. There is a formula that helps us find the axis of symmetry, and that, oh goodness me. All right, and that formula is x is equal to the opposite of b over 2a. This axis of symmetry is a vertical line, so we need to write the axis of symmetry as an equation in the form of x equals a number, which is the form for a vertical line. The axis of symmetry also tells us the x-coordinate of the vertex, since the axis of symmetry goes right through that vertex. So let's find the axis of symmetry for the equation y is equal to x squared plus 2x minus 8. In this equation, my a is equal to 1, because that's the coefficient of x squared. My b is equal to 2, and c is equal to negative 8. We don't need that c term right now, but that will help us later on. So plugging it into the formula, I have x equals the opposite of b. Since our b is a positive 2, we need a negative 2 in the equation over 2 times a. And that'll simplify to negative 2 over 2. Now, when we write our final axis of symmetry, I don't want any of this work in the middle. I just want it simplified to one equation. X equals, fully simplified, negative 2 divided by 2 is a negative 1. So that, my friends, is our axis of symmetry. Now that we know the axis of symmetry, that can help us find our vertex. So the steps for finding the vertex: first we find the axis of symmetry. We plug that x value into the original equation and solve for y, and then we write the vertex as an ordered pair. Just as a reminder, you should be copying these notes onto your note page. Now let's look at that same equation, y equals x squared plus 2x minus 8, and let's find that vertex. So I know the x value is a negative 1, and I'm plugging a negative 1 into this original equation. Plug in negative 1 for x. All right. So I'm going to plug in negative 1 in parentheses. So I have negative 1 squared plus 2 times negative 1 minus 8. Since we're squaring a negative 1, it'll be negative 1 times negative 1, which is a positive 1. And then 2 times negative 1 is a negative 2 minus 8. So my y value is 1 minus 2, which is a negative 1, minus 8 gives me a negative 9. And so to write the vertex, I need to write it as an ordered pair. We plugged in a negative 1 for x, so the x value is a negative 1, and the y value is a negative 9. And so that is the vertex. All right. So now we have found these two important parts of the graph. We can use them both to speed up the graphing process. Here are the steps for graphing. And remember, you can always use a table if you get stuck. So when graphing, we should first find and graph the vertex. Next, we can find the y-intercept. In our equation, that it's going to be the c value. We're going to graph this point and then reflect it across the axis of symmetry. The third thing we are going to do is choose an x value close to the axis of symmetry. I usually choose a positive value because I seem to see less calculation errors with a positive value. We are going to plug it into the equation, find the y value, graph, and reflect this point. We are still looking to put 5 points on our parabola, and the nice thing is now that we know how to find the axis of symmetry, we can use the fact that these parabolas are symmetrical to speed up the graphing process. Also note, if the y-intercept is large, you do not have to have the y-intercept on your graph. You can just make a table and put x values close to the vertex and then reflect them across that axis of symmetry. So we have two examples that we're going to look at. The first one is the one that we've already started. Y is equal to x squared plus 2x minus 8. We have found our axis of symmetry to be x is equal to -1, and we have found our vertex to be -1, -9. The y-intercept is this c value right here, so I have a y-intercept of 0, -8. So why don't I just go ahead and plot those points right now? So I have 0, -1, 2, 3, 4, 5, 6, 7, 8. And then my vertex is at -1, -9. I'm also going to use a dashed line and draw in my axis of symmetry. And again, we use that dashed line to show that it's not an actual part of the graph, but we use it to find points easily. And now that I have that axis of symmetry, I can reflect my y-intercept across that axis of symmetry. Since the y-intercept is 1 unit away, I can go 1 unit on the other side and plot a point. All right, so let's see. I already have used x is equal to 0, so I'm just going to use x is equal to 1 and plug it into the equation. 1 is a small value, it's positive, it'll be easy to calculate. So that means I'm plugging it in. I have y equals 1 squared plus 2 times 1 minus 8. So that means I have 1 plus 2 minus 8. So that y value is 3 minus 8, which is a -5. So then I have the ordered pair 1 comma -5. So I have a positive 1, 1, 2, 3, 4, -5 puts me right here on the graph. And then I can reflect this point across the axis of symmetry, and this one is 2 units away, so I'm going to go 2 units on the other side. I have 5 points, and then I can draw a nice smooth curve through my graph, put my arrows on the end, and not the best looking parabola, but it gets the job done. All right, let's do one more example. So here we're going to look at the equation. Y is equal to -x squared plus 4x plus 5. And so looking at this equation, I see this negative on the outside. And that right away tells me that my parabola is going to open down. So I'm going to be ready for that to happen. All right, so first, finding the axis of symmetry, I have x is equal to the opposite of b. Oh, let's go ahead and write out. My a is -1, my b is 4, and my c is 5. All right, so back to our axis of symmetry, I have x is equal to the opposite of b over 2 times -1. And so that means I have -4 over -2. So I'm going to rewrite my equation as x is equal to a positive 2 in order to find, well, let's just go ahead and put that on the graph. And so positive 2, put my dashed line. I have my axis of symmetry. All right. My vertex, I'm going to plug x equals 2 into my equation. So I have y equals the opposite of 2 squared. Notice how the negative is on the outside of those parentheses. Plus 4 times 2 plus 5. So my y is equal to first I'm going to square 2, which is 4, and then multiply by that negative 1. So I have negative 4 plus 8 plus 5. So my y is equal to negative 4 plus 8 is 4, and 4 plus 5 is 9. So that puts my vertex at 2, 9. And then my y-intercept is going to be my c value, so my y-intercept will be 0, 5. So I can go ahead and get those points on my graph. So I have 0, 1, 2, 3, 4, 5. And since I know where my axis of symmetry is, I can reflect that on the other side. My vertex is going to be at 2, 9. So I have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my vertex right here. And then I'm going to pick an x value that's close to that axis of symmetry. So I'm going to look at x equals 1 and plugging that into my equation. I have y equals the opposite of 1 squared plus 4 times 1 plus 5. So my y is equal to the opposite of 1 squared, so that's negative 1 plus 4 plus 5. So negative 1 plus 4 is 3, and 3 plus 5 is 8. So that gives me the point 1, 8. So putting that on our graph, I have 1, 2, 3, 4, 5, 6, 7, 8. And then I can reflect that on the other side. And then I have my 5 points. Let's see if I can make this parabola look a little better. Slightly better. All right. So there are a couple of examples, and we will do a lot more practice in class tomorrow. Thanks for listening.